topic of this video is the Google Cloud Vision API on the Raspberry Pi, brought to you by Blackmagic AI. So if you want to learn more about us, go to blackmagicai.com, subscribe to our email list, subscribe to this YouTube channel, or like us on Facebook. In the previous Tiny YOLO 3 on a Raspberry Pi using the GoPro camera project video, we demonstrated object detection directly on the Raspberry Pi using the Tiny YOLO 3 model that we exported from our Google Colaboratory notebook. So if you have not seen that video, check out the link in the description section of this video. We also have links to our previous topics in which we introduced Google Colaboratory and Vertex AI. So if you want some more background on those, go to those links to review these previous topics. This is an experiment to determine if the time to perform object detection on a Raspberry Pi can be improved from the previous Tiny YOLO 3 on a Raspberry Pi video project. In the previous video, object detection averaged around 3 seconds, but can that be improved by moving the object detection work to the cloud? Will the improved speed of higher performance processing in the cloud compensate for increased time due to network latency? So the Tiny YOLO 3 project can be deployed to Google Vertex AI, but sending an image for object detection exceeds the maximum request payload size of 1.5 megabytes. So Vertex AI cannot be used as the cloud processing component with that Tiny YOLO model. But there is another approach we can use, in which is the subject of this video. And in this approach, we use the Google Cloud Vision API, which is a pre-trained object detection model available in our Google project once we enable it. This experiment is not intended as a recommended technique to perform real-time cloud object detection on a Raspberry Pi. That will be covered in another video, so subscribe to be notified when that video is released. And once again, this project references previous projects, and the links to these projects are listed in the description for this video. Cloud Vision API, what is it? Well, this quote is taken directly from the Cloud Vision API documentation, and it simply states that the Vision API offers powerful pre-trained machine learning models through REST and RPC APIs. Assign labels to images and quickly classify them into millions of predefined categories. Detect objects, faces, read printed and handwritten text, and build valuable metadata into your image catalog. Purpose of this video, we will only be using the object detection feature of Cloud Vision API, but it is capable of all these other services that we mentioned before. Now the topics in this demo are, we will enable Google Cloud Vision API within our Google Cloud project, and we will create a service account and get an API key. Then we'll open our Google Cloud Vision Colaboratory notebook and run the sample code. So I already have a Colaboratory notebook with the sample code already written that you can use and reference in your own projects. Then we're going to clone the Cloud Vision API GitHub repo onto our Raspberry Pi, and then we're going to run the GoPro Cloud Vision demo program, which actually performs real-time object detection on the Raspberry Pi using Cloud Vision API. First step is to enable the Google Cloud Vision API within our Google Cloud project. So to do that, we have to go to Google Cloud console dashboard. So remember, we'll just type in console.cloud.google.com. The prerequisite is that you already have a Google Cloud project created. So I'm going to use the previous project that we had in our machine learning exclusive OR model tutorial video, but you can also create a new one if you want, but I'm going to reuse that one. And if you want to know how that was done, once again, refer to the links in the description section of the video to go back and review that video that shows how to set up a Google Cloud project. First step in enabling Google Cloud Vision within our Google Cloud project is I'm going to go to the left hamburger menu, and then I'm going to click on the left navigation panel and click on the dashboard. This page contains a summary of all the APIs and services, and also includes a list of the APIs we already have enabled for this project. So you can see here we already have Vertex AI API already enabled, but we want to add a new API. So let's click on the button to enable APIs and services. And then I'm going to type in the API I want, which is the Cloud Vision API. And then I'm going to click on that. And now this is the first result. So I'm going to click on the first result, Cloud Vision API. And then I'm going to click the Enable button. Now you can see that our Google Cloud Vision API is enabled for our project. The next thing we want to do is create a service account. So to do that, we will go to our left hamburger menu again, expand the left navigation panel, and then you'll see I am an admin section. We will go down to service accounts. And then we're going to click create service account. Right, and we'll give it a name, and I'm going to call mine Cloud Vision API account. I'll skip that side, and I'll give it a little description. Service account for API development. Let's do create and continue. Oops, I had a spelling error there. That's okay. Okay, and then in the part where it says select a role, we're going to go here, and we're going to, under quick access, we're going to click basic, and then we're going to click owner, and I'll click continue. Grant use access. This is optional, so I'm just going to click done. And there you see it's been created. The next thing we want to do is create a service account key. To do that, we will click on this email address for the account we just created. And then we're going to click keys. And then we're going to click add key. Create a new key. And I want the JSON format, which is recommended. We're going to do create. All right, and then I am going to download that. So remember, save this file because we're going to need it later when we go to our Google Colaboratory notebook. So take note of where you save this file. And then now that it's been downloaded, I'm going to close. Cloud Vision API is enabled for our project, and it has a service account that we can use to access it. The next thing we want to do is go to our Google Colaboratory notebook and start running the sample code. All right, so once again, we can go to blackmagic.ai.com because that's the hub or starting point for all things Blackmagic AI. So you can access all our other our social media accounts, YouTube, LinkedIn, and GitHub. But we're going to select the GitHub account for now. So click on the GitHub icon. All right, then we're going to go to repositories. And then we are going to click on the Cloud Vision API. And then there's a little README there, so it might be updated by the time you view this videos. Then we're going to click on notebooks. And we're going to click on the actual Colaboratory notebook that is saved here. And remember, in GitHub, you get a preview of the notebook, but to actually run the code and use it, we have to click on the Open in Colab button. And now we are in our Google Colaboratory notebook. So remember, if you're not familiar with Google Colaboratory, refer to the links in the description section of this video that give an introduction to Google Colaboratory before you proceed with the rest of this video. So here are the cells. We have a reference to the Google Cloud Vision documentation if you want to click that. And then let's run each cell in turn as we need them. So the first thing we need to do is make our images an input and output directory. And we're going to load a default image. This is of a dog and additional scenery that we can use for our object detection. But you can also upload your own. All right, we want to run this, so just say OK. You can also upload your own into the Google Colaboratory file system. So we got that. We have our directories made. So if we want to double check that, we can click on our local file system. We see our directories created. and then we see our dog. Our dog image has been uploaded. The next thing we want to do is you'll see a placeholder here that says insert credential file path here. So remember that JSON key file we downloaded previously when we were setting up the service account? Now we're going to need that. So what we can do is click on the upload button, and then we will go to, and then we'll just upload that file. Open. Okay, that's fine. The file is there, and we have to paste in the path to that file in our local Colaboratory file system. So I'm going to click the little side menu here, and I'm going to do copy path. And once we do that, all we have to do is paste it here. All right. And once that's pasted, we will run this cell. So all this does is it allows us to access our cloud endpoint that's been set up for us. So it has security enabled, so you need this credentials in order to access that. So that way it's not open to the public. Now another thing we're going to need later when we start working with the Raspberry Pi is the bearer token. So this cell will just write that bearer token to a text file, which we can download and copy to our Raspberry Pi later. So let's click on that. And then before I forget, I'm going to refresh. And the next thing is do additional imports and create our utility functions. So these are additional image processing functions. Now is the part where we actually send a request to our Cloud Vision API and we get a response back. And then once we get that response, which is JSON data, we're going to use that to annotate and display the bounding boxes on the objects that it detected in the image. So this first method, we're going to send a post using the Python request library, which allows you just to send HTTP requests to some URL programmatically using code. Now remember I said that the Cloud Vision API can do additional things such as character recognition and handwriting recognition and things like that, but we're going to be using the object detection feature, so that's where we specify that here. And also this is the URL for our endpoint to access the Google Cloud Vision API in our project. So if you wanted to use some other features, you would change that here, and then you would get a different kind of results depending on what Cloud Vision feature you're trying to use. But one quick thing, we'll just take a preview of our dog image. So you see in this dog image, we have a dog, a bicycle, and some things in the background. So that's our original image. So let's run this and make sure everything works okay. No error messages. When we get a response, it returns JSON data with the location of the bounding boxes within that image. So we have some, we're going to process that JSON, and then we're going to call a function to draw the bounding boxes on our original image based from the data we received. So we don't receive any image data back from the API. All we receive is JSON data with information we need to locate the objects in our image. Then we're going to display it. So let's click on that. So it's processing, and there you have it. So now you see the objects are detected. So we label the actual object that was detected and the confidence percentage for that particular object detection. So you can compare this with our previous project in which we used the Tiny Yellow project. So it looks like we have the similar results. We get all the objects detected. We get the tires, the bicycle, the dog, and the car in the background. Now another way you can do this is using the curl command. So the curl command is you can actually use this from the terminal, and you don't need to use Python. You can use it directly in your command line terminal. But once again, you'll have to paste the credentials file. So let's see, we still have that in our clipboard. All right, and then everything else is pretty much the same. It's just we're using a different way of accessing the endpoint. So I'm going to run that. So if you don't want to use Python code, and this gives you an example of the output that gets returned in our response. So it has like the name, the score, and then the vertices for the bounding box. So that's what the results are. And you can also use the curl command from Python. So if you want to call operating system command from Python, you can do it using this. So let's also try it this way. And once again, we get the same results. It's just we use the curl command and we use it using the Python code, not using the request library. All right, so that's a demo of how we can access and use the Cloud Vision API. So now let's try it on real-time image data from a GoPro camera connected to our Raspberry Pi. We've completed running our object detection code in our Google Colaboratory notebook, and now I'm on the Raspberry Pi desktop with my browser window open. I have the blackmagicai.com tab open. I have my GitHub repo and Colaboratory. Now we're going to run a modified version of object detection on our Raspberry Pi. And what we need to do is go to the Blackmagic AI GitHub site, click on repositories, Cloud Vision API repo, and then once that opens up, we're going to click on the code button, that green code button, and once you click on that green code button, we're going to copy the clone link. So this is the link we'll need to copy the repo onto our local Raspberry Pi file system. All right, so we've done that. So let's open up a terminal so we can go to our applications menu, or you can open it from the top toolbar, but we're going to use applications menu, accessories, terminal, and then once the terminal opens up, we will first, let's try to list our current directory just to see what's in it. So to do that, we are going to type ls space -l. So this lists our current directory listing. And then once we do that, we're going to do a git space clone space, and then we're going to paste that URL that we copied from the GitHub repo. And then once we hit enter, it's going to grab that repo and copy it onto our local file system. So let's list our directory again, and we can see there the Cloud Vision API folder has been added to our Raspberry Pi file system. So let's go into that folder. So let's cd into the Cloud Vision API folder. And now that we're in that, let's do another listing. And now we're going to cd into the PyCode directory, because that's the one that has the code we're actually going to run on the Raspberry Pi. All right, so let's do another listing. And then you can see the GoPro Cloud Vision.py. That's our demo code that's going to use our GoPro camera image. It's going to send it to our Cloud Vision API, and then we're going to get object detection data back, and it's going to display it in our preview window on our Raspberry Pi. So this, we've shifted our object detection from running it on the Raspberry Pi to actually in the cloud. So another thing we want to do, we want to modify that file. So let's open up our File Explorer and go into our Cloud Vision directory again, and let's open that PyCode folder, and then we're going to open the GoPro Cloud Vision Python file and our local editor. I'm using idle, but you can use any editor you want. So let's look at that. So this is the code that we're going to run on our Raspberry Pi that's going to do our Cloud API Vision in real time. Now if you see there's some code in red, it says start of gcloud authentication code. Now if you uncomment the code between that and the end gcloud authentication code comment, that will use gcloud to do our authentication and get our bearer token. So remember, we need a bearer token to access our Cloud Vision endpoint that we created. So just uncomment this code if you want to do that, but you need gcloud installed. So for this demo, we're not going to install gcloud, but you can look up the instructions on how to install gcloud on the Raspberry Pi if you want to do it that way. So, but instead of doing the gcloud, what we're going to do is just generate it in the bear token. We're going to generate the bear token in our Google Colaboratory notebook, and then we will copy it and paste it into this code where it says insert bear token copy from notebook here. So that little placeholder will be replaced with our actual bear token. Now, the one disadvantage of using the bear token like we're going to use in this demo is that it does expire, so you'll get like a unauthorized error when it expires. But if you use the gcloud method for the code listed above that's commented, you will not have to do that. It will refresh every time you run the code. But for the duration of this demo, our token will be valid, so we don't have to worry about it for now. But the gcloud is just another option. So we're going to go to our Google Colaboratory notebook, which we already have opened up in our Chromium browser on our Raspberry Pi. So remember, we need this API key JSON file on our Google Colaboratory file system. So remember, we uploaded that earlier. And what we want to do now is run our Google application credentials environment code. So what we're going to do is copy the path for the API key JSON file, and then we're going to paste it in line 4 of this first cell where it says insert credentials file path here. So that it'll just go in, pick up that file, read the contents, and it'll generate our bearer token for us using gcloud, which is already installed on in Google Colaboratory. So that's why we didn't have to install it there. All right, so yes, we want to run that. So we're going to run that cell. It's going to generate our bearer token, and now we're going to run the next cell, which is going to write that bearer token to the token.txt file, which we can use to download to our Raspberry Pi, and then we can copy the bearer token and paste it in our demo code. All right, so we've run that cell, so let's refresh our local file system directory in our Google Colaboratory, and there's a token.txt file. So what we want to do now is download that. All right, so it's finished downloading, and then we're going to open that file. So let's click on this, open it. And once the file is open, you will see our bearer token, which is a long string, very long text of letters and characters. So we're going to select it. We're going to do a copy, Control C, or however you want to copy. And then we're going to go back to our demo code, Python code, and we're going to replace the placeholder with that bearer token text. So let's just get rid of the placeholder, and then inside the single quotes. So we're going to delete that, and then we're going to paste our bearer token that we had from our token.txt file. Now, once we do that, it's a very long string. So the editor here replaces some of the characters with ellipses, just because it can't display them all. So, but trust me, it's still but the characters are all there, so you don't have to worry about that. All right, and then we're going to close our browser just to conserve some resources here. So there'll be less strain on our system when we're running this computer vision code. So to run the code, type Python 3 and then our GoPro Cloud Vision.py, the name of our file. So this is going to run the code using Python 3. Then we get our preview of our GoPro camera, and I'm going to start putting objects in front of the camera, and you can see it's recognizing some of the objects. I move them around, like the toy soldiers, it recognizes those as a person. My toy car, it shows as a toy vehicle. The horse, it shows up as an animal. The little cow shows up as a dog sometimes, and sometimes it's an animal. So you can see we get roughly the same accuracy as we did when we ran the TinyYOLO 3, which was running directly on the Raspberry Pi. But in this case, as you can see, I printed out some of the detection times here. So they're averaging around 0.4 seconds. And recall that when we ran the TinyYOLO 3, we were averaging around 3 seconds when we were actually running the object detection code on the Raspberry Pi. So shifting the workload to the cloud improved our performance and gave us a shorter object detection time, in addition to the network latency we have. So looks like in this experiment, cloud object detection is a better performance over running it directly on the Raspberry Pi. We've gone from 3 seconds to detect the object to 0.4. And that concludes this video. Go to blackmagicai.com, like us on Facebook, sign up on our emailing list. You can also subscribe to this YouTube channel and you'll be notified when additional videos in this series are posted. Thank you for watching.